Hello, today we're gonna solve two similar problems. In each problem, we will assess the brightness of the lamps in a circuit. Let's start by problem number. In the first problem, we are given a circuit with 4 light bulbs, and we have to rank their brightness. Let's redraw the circuit and analyze it. Okay, bulbs A, B, and C are in series because the current that goes through A goes through B and goes through C, right? And D is in parallel to those 3 bulbs. Why? Because at this juncture, current splits into current that goes through D and the current that goes through A, B, and C. So the equivalent circuit for this circuit network can be represented as this. I that's coming out of the battery splits into I sub D, the current that goes through D, and I sub ABC, the current that goes through A, B, and C. And the currents that are going through A and B and C are the same. And at this juncture, they combine together and go back into the battery. So let's assume the resistance of these 4 bulbs is R. I mean, they're identical bulbs, so they all must have the same resistance. Let's calculate the resistance of this part of the network. Well, since all of them are in series, the resistance of this would be resistance of 3 resistors in series. And since all of them are same, the resistance of A, B, and C is going to be just R plus R plus R, which is 3R. Okay, now what we're going to do, we're going to assess the voltages across this part of the network and this part of the network. Since this one is in parallel with these 3 bulbs, right? So since bulb D is in parallel with bulb D, voltage drop across this bulb and these 3 bulbs should be the same, right? Because they're connected to the battery at the same junctions. So voltages are equal. So voltage drop across ABC should be same as the voltage drop across D, which should be the same as the total voltage of the battery. And from Ohm's law, we know that voltage equals to current times resistance. So here the resistance is 3R and current is I sub ABC. Here the resistance is just R and current is I sub D. If we cancel R's from both sides, we find that I sub D over I sub ABC should be 3. So 3 times more current goes through here than here. Okay, now let's express this in terms of the current that's coming out of the battery, right? So we know at this juncture, the current that's coming out of the battery splits into 2 currents, I sub ABC and I sub D, right? So the sum of these 2 currents should be equal to the current that's coming out of the battery. And we know that I sub D equals to 3 times I sub ABC. Or from here we can calculate the current that goes through the upper part of the network, or I sub ABC should be 1/4 of the current that's coming out of the battery. Well, then we can easily find what is I sub D, which is 3 times the current of the ABC network, right? So you have I sub D should be 3/4 of the current that's coming out of the battery. Well, we know the resistance, we know the current. Now let's try to assess the power, okay, of the light bulbs, because power is essentially tells you how bright the light bulbs are. So the equation for the power is current squared times resistance. Power of the light bulb A, B, and C are equal because they have each of them have the same resistance and each of them have the same current going through them, right? Which is 1/4 of the I. So if we square I over 4 and multiply it by R, we get I squared times R divided by 16. We can do the same thing for D, but the current here is 3 times the current that's going through here, right? We just found it here. So the power of D comes out to be 9 I squared times R divided by 16. So this is 9 times more power. So the brightness of D, this would be the brightest, and the brightness of A, B, and C are the same. So the brightest is going to be D, and it's going to be brighter than A, B, and C bulbs, which are have the same brightness. I hope this is clear to everyone. Now, let's look at the second problem. Again, we are given a circuit, this time with 6 identical bulbs, and we have to rank them according to their brightness. Again, we're going to start off by redrawing this circuit so it's clear to us how to assess the resistance, current, and based on that, the power generated by these bulbs. If you look here, current that's coming through here is, so this part has no resistance. So these points are equivalent. So you can draw this as current coming to this point and splitting into 3 and going through the bulbs A, B, and C. Well, since they have all of them have the same resistance, current will split equally. So if the current that's coming out of the battery is I, you're going to have I over 3 going through here, I over 3 going through here, and I over 3 going through here, right? Once this current passes through these bulbs, what's going to happen here? It's going to reach this point. Now again, these points are identical, equivalent, right? Because there is no resistance in between of them. So you can just move D to here. It's essentially the same thing. Hence, we can draw that part of the network like this. And what happens here? All these 3 currents come together and combine back to a current I. And then this current has to split. Since the resistance is equal here, it's going to split into equally 2 halves. Right? So I over 2 going through each of the bulbs. And at this point, they combine back and go through bulb F. So the current that's going through the bulb F is I. And it goes back into the battery. Now we know the currents going through each of these bulbs. Now we are in a position to assess the power or the brightness of these bulbs. Well, again, the equation for the power is just going to be I squared times R. Power of A, B, and C are same because they have the same amount of current going through the same amount of resistance, right? So it's I over 3 squared times R, which is I squared R over 9. We do the same thing for D and E. Here you have they are again same powers, and it's I squared over 2 squared over R, which is I squared over R divided by 4, and the power of the bulb F is I squared times R because the current in its entirety passes through F. And now if you have to rank the brightness of the bulbs, obviously F is the brightest, and the next one would be D and E, which have similar brightness here, and the brighter or the least brightest would be A, B, and C. So F is brighter than D and E, and these are brighter than A and B and C. I hope this is clear to everyone, and that's the solution for these 2 problems. Thank you.